Good morning. I'm going to present you our use case, which is an agentic system which helps users select most suitable post-quantum cryptographic algorithm for their systems without having an PQC expert. The proposed system is a web-based conversational interface designed for querying post-quantum cryptographic benchmark data. To develop this system, we employed the Model Context Protocol, which is an open standard that facilitates interoperability between AI models and external tools or data sources. The data are collected mainly by using two components, the Context Agility Manager and the Kuhata. The Model Context Protocol is an open protocol introduced by Anthropic. It standardized the interaction between AI models and external data sources and tools, and enabling structured communication between them. In our system, we implemented 19 tools organized across 4 categories. As illustrated in the diagram, the users submit a question through the chat interface. The question is posted to the LLM, which analyzes it and decides which tool it needs to answer it. And then the LLM calls that tool through the MCP server, which executes against the real data. The results returned to the LLM, which use those results to formulate the final answer and present it to the user. This is our interface of our system. On the left side, we provide a set of suggested questions to guide the user. The user can either select one of those predefined questions or formulate their own query directly on the chat. Let me explain how the benchmark data is actually produced. The Context Agility Manager is our benchmarking component. It runs NIST post-quantum algorithms on real hardware and collects the measurements like handshake time, PQC, CPU power consumption, and energy. To take this data for our demo, we use 2 NUCs on which we have installed the Kuhata. First, the Context Agility Manager called Kuhata by sending the experiments parameters, the algorithm to be tested, the message size, and the number of iterations. Then the Kuhata executes the experiments by performing real TLS handshake using LibQS, which is an open source library that implements the NIST post-quantum algorithms. The results are stored in the database, and then they are ready to use from users to answer the questions of the user. Now let's see some of the tools that are available in our system. By using the Context Agility Manager, the system can answer questions such as which algorithm is faster, which algorithm has the lowest power consumption, how the 2 algorithms compare against each other, and which algorithm satisfy a specific NIST security level. Additionally, through Kuhata, the system can run live TLS handshake experiments. The user specifies the algorithm, the number of iterations, and the message size, and the system returns real measurements about the duration. Thank you. And we have a video demo. Here the user selects two algorithms from a drop-down list, but it's not seen here. And we have the answer from the Context Agility Manager and the Kuhata. And we run another questions. That's all. Thank you.